Hello everyone, welcome to our next lecture. In previous lecture, we had discussed about context-free grammar and normalization, that is CNF and GNF, Chomsky normal form and Gribach normal form. Now, in today's lecture, we will move on push down automata, which is known as PDA. Now, what is PDA? Earlier, once we had done our regular language, we had picked that to represent regular language, we have finite automata. We had designed so many finite automata, deterministic finite automata, non-deterministic finite automata. So, for regular languages, we had one representation, that is finite automata. For context-free languages and context-free grammars, we have for representation or automata for it, that is PDA, push-down automata. So, what is push-down automata? So, let's pick. First of all, let's focus on designing of it. Let's try to pick which we had earlier done, that is finite automata. What we had in finite automata? In finite automata, we had our input tape. I hope you remember this thing. And there is one black box where you have all the functioning. Transition functions are defined here, and on the basis of these functions from input tape, machine takes input and process acceptance or rejectance. That we had picked with respect to finite automata. Now, what was the drawback of finite automata? We had already discussed the pumping lemma of regular languages, and we had picked that the major drawback of finite automata is that it cannot pick one simple language like a to the power n, b to the power n, where n is greater than equal to 1. We had proved from our pumping lemma for regular languages that this particular language cannot be processed by finite automata. Now, what was the reason behind it? The reason was that for processing these type of languages, system or machine require memory. Now, for a to the power n, b to the power n, why we require memory? We require memory because we want to showcase that number of A's are equal to number of B's, where A will be followed by B. So whenever we want to process any comparative analysis, we require memory. But in finite automata, as you can see here, apart from input tape, we do not have any kind of memory for processing it. So that was the drawback of finite automata. And hence, we are not able to process that simple language, equal number of A's and equal number of B's, where A will be followed by B. Now, the same drawback was removed in context-free languages and machine of context-free language, that is PDA. In PDA, it says that yes, we have once again input tape. Once again, we have functioning box which controls that head and have so many functions. And now here we have one additional memory, that is stack. Now, I hope that you know that what is functioning of stack. Stack says last in, first out. Whatever will be the last in number, that will be taken first. So that is last in, first out. And operations which we perform in this, that is push and pop, which are standard operations. Now, by just simply adding this particular stack, the power of this machine, which was earlier finite automata, got enhanced. Now, let's check that how the power of this machine got enhanced here. So, I am taking one example and I'll try to prove that how just by adding one small stack or one small memory portion into machine of finite automata, how we have extended the capability of that machine. And this machine is known as PDA. So let's take one example of it.